So in chapter 2 we're going to talk about the ideas of measures of location and of spread. Now you've not really come across these terms before, although you have come across a lot of the ideas that the terms refer to. Measures of location include things like quartiles. Now you've met those when you studied box plots and cumulative frequency at GCSE. And you know that the lower quartile is the value that shows you where the lower 25% of the data values reach. And you know that the upper quartile shows you where the first 75% of the data values reach. And you also know that the median is the 50th percentile or the second quartile, because that shows you where 2/4 or half of the data reaches. So you've also, without realising it, met the idea of percentiles before, because as well as splitting the data into quartiles, 25% blocks, we can split it into any percent blocks. So you could talk about the 10th percentile of the data, knowing that that's the value where 10% of the data is lower and 90% of the data is higher. You could talk about the 80th percentile, whereby 80% of the data is lower and only 20% of the data is higher. So let's jump now to these three. These three here, mean, median and mode, are particular measures of location, and they're particular ones because they all are attempts to measure what we call the central tendency of the data set. Attempts to measure roughly where the middle of the data is, but the middle of the data isn't really kind of a well-defined idea because there are different ways of doing it. So one of the ways we have of doing it is by listing all the data values in order and finding the value that's in the middle. If we do it that way, that's called the median of the data. So the middle data value when the set is ordered. You could order it ascending or descending, it wouldn't make a difference to where the middle data value was. But that's not the only way of thinking about the middle of a data set. We could talk, for instance, about the mode, which is the data value that comes up the most often. And there are cases where it makes more sense to talk about what occurs most frequently as opposed to what's strictly in the middle. So the mode is the most common or the most frequently occurring data value. When our data is grouped in a frequency table with classes, then we talk about a modal class, and modal is just the adjective that comes from the noun mode. The way that's most generally used in the media and when people talk about the idea of an average is the mean. And we know that the mean is found by summing up all the data values and dividing by how many there are. We're going to write that more succinctly, more mathematically, with this formula here. The mean we represent by the symbol x bar, where the letter x refers to the data values. So x bar is the mean of the x values, and we find that by summing up the x values and dividing by the number of x values. So this symbol here, the Greek letter sigma, capital sigma, is the symbol for summing up. X here represents each of the x values in the data set, and n represents how many values are in the data set. So if you had a list of 10 numbers, you would sum up all those 10 numbers and divide by 10. Now, you know how to find mean, median and mode. That's quite straightforward. So let's jump straight in with an example that asks us to think a little bit more in depth about them. We have an example 1, 2 sets of data. We'll call data set 1 x, we'll call data set 2 y. We're given some summary statistics about these data sets. We are told that the number of values in the x set is 25. So it's a set of 25 numbers. And we're told that the mean of all those numbers is 6.4. So what does that mean for us? It means that if we sum up all of those x values and divide by 25, we get 6.4. Now this works just like solving any equation at all. We could work out the sum of the x values by multiplying 6.4 by 25. So I can say, therefore, the sum of the x values is 6.4 times 25, and that is 160. Now, set y is a completely different set of numbers. We know that there are 30 numbers in this set, and the mean of those 30 numbers is 7.2. So let's do the same thing. The mean of the y values is the sum of the y values divided by how many there are, and that's 7.2. Therefore, the sum of the y values will be 7.2 times 30. And that's 216. So, I don't know what any of these x values are, I don't know what any of these y values are, but I do know that all these x values add up to 160 and all the y values add up to 216. Now, the question is saying that if you take all these sets of numbers, or these two sets of numbers, x and y, and you put them together, this one and this one, you will have 55 values all together. So let's call this overall combined data set, we'll call n, the number of values in it, and that's 55. So this is for the combined set x plus y. N is 55, so we know we've got 55 values. We're asked to find the mean. So to find the mean of this data set, I've not given it a letter, so I'm just going to write the word mean for now. I could give it a letter, I could call it Z, for instance, and then use Z bar, but I'll just write mean for now. We know that we need to work out the sum of all 55 values. Well, that will be the sum of the x values plus the sum of the y values. So 160 plus 216 divided by how many values we've got. So that gives us 160 plus 216 divided by 55, 6.84, and that's correct to 3 significant figures there. So that's the combined mean of both data sets. Now, I want to point something out here. When I had the mean of x's and the mean of the y's, 6.4 and 7.2, what would happen if I just found the mean of these two? 6.4 and 7.2 over 2. That gives me 6.8, not 6.84. It's a very common mistake for people to think, I've got to find the mean of these two combined. So these two combined sets, so I'll just find the average, the mean of each of these two means. But that would be wrong, and the reason it would be wrong is because these data sets are different sizes. So this set carries more weight in the combined set than this one does, because this has more values in it. So it's not a straight mean of those two. You have to work out the sum of each of those two and then use that sum to find the mean of the combined set. Now, each of these three different measures of mean and median and mode are useful in different scenarios, and you need to be very, very clear now about when each of them is or isn't quite so useful. So the mode tends to be used most often for qualitative data. Now you'll remember from chapter 1 that qualitative data is generally non-numerical, so something like hair colour would be qualitative data. And the mode is of course useful for that because it's just talking about the thing that comes up the most often. Now you can use the mode with quantitative data, numerical data, but you tend to only use it when it's clear that there is a mode. So for quantitative data, let's just put quant there for the sake of time. For quantitative data, you will use it if there is a clear single mode. If one value stands out as occurring definitely more than the others. You'll use it if the data, sometimes you can say the data is bimodal. That means there are two values that occur the most often, but equally the most often. But it's really no good at all if every data value occurs the same amount, if each one occurs only once, for instance. And it's arguable how good it is, even if there is only a slight mode. Maybe one value occurs twice and all the others occur once. Yes, that value is the mode, but is it useful to point that out? It depends on the context of the question. So the mode, you've got to be careful about it, and you've got to be careful about when you use it. And as you'll see as we go through this year and next with statistics, it's all about interpretation. It's all about how you use the numbers you give to explain what you're trying to explain. So sometimes a statistic may exist, but it might not actually be particularly useful. And that happens quite often with the mode. Now, the median is used for quantitative data. I still can't say it. Quantitative data. Numerical data. And it's really good when there are extreme values. Because it ignores them. If you were to list numbers in order, and let's say your numbers were 1, 2, 3, 5, 50, then that 50 would not affect the size of the median because the median just picks the one that's in the middle. However, the mean is affected by extreme values. If your numbers were 1, 2, 3, 5 and 50 and you worked out the mean of those, let's see, 1, 2, 3, 5 and 50, divided by 5, the mean there is 12.2, which really doesn't reflect that data set because most of the values are between 1 and 5. So the mean is great, but not so good when you have extreme values. So it's used for quantitative data, but not good when you have extreme values. So you need to be careful about when you use the mean, the mode, or the median. And you'll see as we go through cases where one is better than the other. Now let's think about frequency tables for a moment. If you have data given a frequency table, we can still work out the values of the mean, the mode and the median. I just want to spend example 2 just considering that to make sure you've remembered how to do that back from GCSE. Here's a frequency table. Generally, you tend to see them presented vertically, whereas this one is presented horizontally. Don't let that throw you at all. It's still exactly the same idea. Now, this data, we're told, records the shirt collar size of some male students. I want you to pause the video for a second and think about, from chapter 1, what type of data is this? So hopefully you decided that this was quantitative data, but more particularly that it's discrete quantitative data, because you can't have a shirt size of 15.2 or 15.36. You can only have particular values. So this is discrete data. Now, if we're asked to find the mode of this data, we're going to look for the value that occurs the most often. So looking at the frequencies, there are 3 students who had a collar size of 15, but many more had a collar size of 15.5. There were 17 of them. The collar size that's the most common here is 16.5 with a frequency of 34. So that means 34 students had a collar size of 16.5. So our mode is 16.5. That's the most commonly occurring shirt size, collar size. Now the median then, there's a little bit more work required here to find where the median is. What I really don't want to be doing is listing out this data set in full, because I would be writing this out. I would be going, the number 15 occurs 3 times. 1, 2, 3. And then the number 15.5 occurs 17 times. 1, 2, 3, 4. I'm bored already. I don't want to be doing that. That's ridiculous. So what I want to be doing instead is thinking about how I would find the mean and then using that knowledge to just get it straight from the table. I said mean, I mean median. So this is how you find where the median is located. We know that there are n data values. So you add 1 to n, you divide by 2, and it's in that position in your list. Let me demonstrate this formula very simply with a smaller list. Imagine you had a list of 5 values. Doesn't matter what they are. 1, 2, 3, 4, 5. This one here would be the median. If n is 5, then we would go 5 plus 1, which is 6, over 2, which gives us the 3rd position. And if we look back at our list, 1, 2, 3, it's in the 3rd position. If, however, we had 4 values in our data set, 1, 2, 3, 4, we know that the median would be here, halfway between the 2nd and 3rd. So we could say the 2.5 position or the 2.5 position. So if n is 4 here, we're going to go plus 1 over 2, which means that's 5 over 2, so the 2.5 position. So this is our formula n plus 1 over 2, and it tells us the position that we find the median, not the median itself. So let's see what n is for this data set. I don't think it tells us in the question. No. So let's add up our frequencies here. We've got 3, 17, 29, 34 and 12. So there's 95 students in this survey, in this table. So n is 95. Let's find the position then. Add 1, halve it. The 48th position is the median. So 48th value. So our median, Q2, is, the first 3 values are 15s. By the time we've had all of the next 17 values, we've got to 20 values in the list. So now the next 29 of them are all 16s. So by this point we've got to 20. Let's make a little note there. By this point we've got to 49. So the 48th value would be one of these. It would be a 16. So our median shirt size is 16. Now, let's look at the mean. For the mean, we need to adapt our formula slightly. Now, you'll remember doing this at GCSE. To find the mean of a data set, to find the mean of a frequency from a frequency table, you take your x value, multiply it by the frequency. X value, multiply it by the frequency. Do that all the way along, although you've been used to doing it on data presented vertically probably. Then you sum up all of those products and divide it by how many are in the data set. So you'll divide it by 95 in this case. So what we're doing there is we are taking our frequencies and multiplying them by the x values. We're summing all that up and we're dividing it by n, which we get by summing up the frequencies. So this is our adapted formula. It's exactly the same formula as this, but it's adapted so that we can use it directly from a frequency table without having to list the values in order and add all 95 of them up. All we're doing when we multiply is we're saying we've got 3 15s. There they are, look, 1, 2, 3 15s. Then we've got 17 15.5s, 1, 2, 3, 4, 5, and so on, all the way up to 17 of them. So by doing these products this way, we are summing up all 95 data values before we then divide by 95. So always write your formula out. It helps you to remember the formula. It helps you to present your mathematics clearly. Please don't jump to just to writing answers. Always write your formula out. So on my calculator, I would now sum up my f's times x's. So I've got 15 times 3 plus 15.5 times 17 and so on. And that gives me 1,537.5. So here we go, 1,537.5. We know there are 95 values altogether, so divide that by 95, which gives me a mean of 16.18. So let's go 16.2. That's a bit weird because if we look at these, 16.2 isn't actually one of these values. You can't have a shirt size of 16.2, which kind of suggests that the mean isn't particularly useful in this context. If it were another set of numbers that didn't have the context of shirt size, it might be fine to use, but in this case, it's not a shirt size, so it's a little bit pointless to use it. So now, part D asks us to explain why a shirt manufacturer might use the mode when planning production numbers. Why might they use this one instead of the median, 16? Well, the mode is an actual data value, as is the median, whereas the mean wasn't, so they're obviously not going to use that one. And the mode in this context tells them the most common size. So that's the size that gets bought or worn the most often. So that's going to be the one they're going to want to make the most of. So when they're planning their production numbers, the mode is going to be a really useful value for them. Now, I'm not going to write all of that down. It's written in the textbook if you need to go back and read it. But hopefully that's made sense to you. What you need to make sure is that you think always about not just calculating these numbers, but what do they mean in the context of the question? Are they useful in the context of the question? And that will vary for every question, but you need to start asking yourself those kinds of questions all the time so that you get used to this idea. Now, I'd like you to go and have a go at exercise 2A now, please.